Hello and welcome. My name is James Marshall, and today I will be discussing whether Scandinavian English is closer to British or American English. The aims from my project are to identify which variant of English is used throughout the Scandinavian regions. I'll be looking at three countries: Finland, Sweden and Norway. I'll also try and show you how data mining and text analytics can be useful for gathering and producing results for linguistics research. Here we can see the Scandinavian region on the top, the US on the left, and Britain on the right. So who might this be of use to? Well, we believe that this is definitely going to be of use to the readers of the Nordic Journal of Linguistics. Also, the readers of the Nordic Journal of English Studies, which looks directly at using English as a lingua franca. However, more specifically, it might be of use to the Nordic academic communities. We now know that master's degrees are taught in English. There are definitely financial rewards for writing in English journals, and the scale of English literature compared to the Nordic counterparts is definitely greater. And as I've previously mentioned, English has become the lingua franca of the world. It may also have relevance in advertisements. Knowing the target audience and who you're pitching to is definitely an advantage. Our initial assumption is that Scandinavian English is going to be most similar to British English. We believe this for a number of reasons. We saw at the start that it is closer geographically. We also know that the growth of English within the academic communities is definitely on an incline. This is shown in Birgit Brock's The Growth of English for Academic Communications in Nordic Countries, a reference given below. Of course, they both share the same continent, and since World War II there have also been strong trade links. To tackle this problem, we'll be using the cross-industry standard process for data mining. This method is a very easily accessible method and produces good and reliable results. We strongly recommend this method. We'll start by using an expert source of UK and US English to identify the key defining features. Now these could be grammar differences, or they could be as simple as spelling differences. We'll also predominantly be analysing written English as opposed to spoken English. We then need to obtain corpora written in English from the Scandinavian countries. To do this, we could use Sketch Engine and Web Bootcat to automatically spider over the internet to obtain these corpora for us. We could use the advanced features to specify English with a domain of Sweden, for example. Finally, we'll use machine learning algorithms to automatically calculate and analyse the results of our features. The main method we used when choosing our features were comparing the relative frequencies of words in American and British corpora. We also used a log likelihood statistic to show the significance of these differences. By looking at these relative frequencies, we have found that spelling ambiguities show a good distinction between American and British English. As such, we decide to then investigate two additional corpora which utilise a more varied form of English. The two additional corpora which were chosen are Project Gutenberg, which is the digitised archive of cultural literature, and also TV and movie scripts. On top of this, we also asked a British and American native speaker to identify a word which they thought was unique to their language. Here we are comparing the relative frequencies between the UK and the US corpora. Note you can see the log likelihood on the far right. And here we can see the word frequency list from Project Gutenberg and the TV and movie scripts. From our research, we believe that these features best categorise UK and US English. During the next couple of slides, we will discuss some key advantages and problems that are associated with our features. I believe the key advantage with using our features is they're very simple to obtain and extract. If we were to use more complex semantic and grammar differences, these would be a lot harder to extract and yield probably not as good results. We have also gone through our list of features and removed words which are unlikely to occur, for example breathalyze. And finally, we believe that our features, although there are only spelling differences, we still believe those to have a very good spread of UK to US suffix differences. There are, however, a few problems with our features. Some of the features that we extracted would be considered ambiguous. For example, autumn and fall. Both can refer to seasons, however in English, fall can also refer to a verb. That said, we did still keep in program and program, as during our testing these features really did seem to be a good indicator of US and UK English. The reason we encountered this problem is because the corpora that we were using was not tagged If we were using a tagged corpora, for example the British National Corpora or the Brown Corpus, a distinction could have been made, for example autumn as a noun and fall as a verb. So now we have decided on our features. Before we can extract them, we first need a word frequency list for each of the corpora. These lists can be made using the NLTK Python toolkit relatively quickly and simply. However, we used Eric Outwell's pre-made sorted frequency lists, available from the link shown here. The word frequency list, as its name suggests, labels the corpora with how many times the word is present throughout. In order to obtain the actual frequency, we can simply open the text file, press Ctrl and F, and enter your search term. If this is considered to be too tedious, a simple Python script could be wrote to replace this act. Note, for when I was finding the features, I didn't consider the case. So for example, colour, all lowercase, equated to colour, starting with a capital C, equated to a capitalised version of the whole word. Note that all other variations are considered to be different. For example, colour does not equate to colours, and it also doesn't equate to colourful. Here you can see how we can use the word frequency list to start to compare the different varieties of English. We have the UK variant on the left here, and the US on the right. In order to train a classifier, it was necessary to produce a .r file. These contained our chosen features and the associated corpora results. We used 20 example corpora, 10 US, 10 UK. These were sourced from the Atwell Worldwide English Corpus. From our table of results you can see that we have tried 6 different machine learning algorithms, most of which have produced the same results. We can see that both Sweden and Norway both use UK variants. Finland, however, seems to use a mixed variant, with 2 of the classifiers classifying it as US English. Scandinavia as a region, however, seems to be dominant in UK. Out of the 6 different machine learning algorithms, I decided to use 3 decision trees. Decision trees have the advantage of being able to visualise the data and seeing which split gave rise to the most information gain. We can use this information to see which were our best features. The decision tree shown here shows the J48 algorithm. As you can see, it simply just used one feature to classify all of the data. The feature it's chosen here is the colour percentage of UK English. The ADE tree, however, shown here, has decided to use centre. And finally, shown here, the LAD tree has used both variants of centre, the English variant of organisation, and the American variant of colour. These results are very interesting as it shows that we don't need a lot of features to accurately classify the data. It also backs up the theory that more complex features are actually unnecessary. When analysing our results, we have also found another use for the log likelihood calculator. Here we have used it to measure the significant difference between variants of English within the same corpus. By using decision trees, we have picked out that centre and colour are both very defining features. As such, we have looked at them using the log likelihood calculator. You can see here we are comparing the UK, US, the 3 countries, and Scandinavia as a region as a whole. We can see here that a positive score represents the UK, whereas a negative score represents the US. However, there is a great magnitude difference between the Nordic countries and the UK and US. This magnitude difference shows that although Scandinavia as a region as a whole is UK, it is actually very, very mixed. This has highlighted a problem with our machine learning system. Now, although it classifies the data, it doesn't give a degree of the classification. For example, here we can see that Sweden, although classified as US, is actually very, very close to UK as well. Again, this is true when we look at colour. It appears that Scandinavian regions use a very mixed version of UK and US English. We have found English within Scandinavia is very mixed. Although the machine learning algorithms showed that British English was more prevalent, using the log likelihood technique we have shown that actually the significance is not that great. Out of all the countries we tried, Finland was the one that was most similar to US English. So why was this? After further research we have found a possible explanation for this. The native languages of Sweden, Denmark and Norway are all North Germanic in origin and to a considerable extent are mutually intelligible. However, the native language of Finland is of Baltic Finnic and vastly different to the Germanic tongue. This difference may help to explain why Finland produces significantly different results to the other 3 countries. If we were to extend this work, I'd look at using more complicated features. I'd also try looking at using a tagged corpora to allow ambiguous words. Could also use the Brown and the BNC corpus as training data and extend to spoken English. Finally, I'd like to thank Eric Atwell for resources throughout the project. We hope that this report has shown you how data mining and text analytics can be a useful tool for gathering and producing results for linguistics research.